Good morning to all. I am Tejansi, Assistant Professor, Department of Physics, Anzian College of Arts and Science, Farm at Trinadhapuram. Today my topic is about nanotechnology. Nanotechnology was initially suggested by Nobel Prize winner Richard Feynman in 1959. So nanotechnology is the creation of useful materials, devices and systems through the manipulation of matter on this nanocellular scale. This emerging field involves scientists from many different disciplines including physicists, chemists, engineers, information technologists. Mainly it's useful in biologists too to prepare the medical applications in recent days. So nanomaterials. So in nanotechnology, a material is defined as a small object that behaves as a whole unit with respect to its transport and properties. So nanoparticles is size between 1 to 100 nanometers. So 1 nanometer means 10 to the power of minus 9 in size. So grouping of nanoparticles on the basis of dimensions. So every particle has different dimensions to prepare the nanomaterials. First one is 0 dimension and second one is 1 dimension and third one is 2 dimension and fourth one is 3 dimension. These are the dimensional scales to produce the small nanoparticles from bulk materials. So nanotechnology has different type of properties. First one is mechanical properties, second one is optical, third one is electrical properties and fourth one is magnetic properties and fifth one is bulk behavior and finally it is a catalytic properties. In all these properties are behaving in single nanometer scale. So these are the properties in nanoparticles that contained in the field to prepare the nanoparticles. So these are the applications of nanotechnology in recent days. First one is human health, next one is energy storage, textile applications, diagnostics, agriculture applications, solar cells, optoelectric applications, environmental applications and water treatment applications. Mainly the nanotechnology field is useful in medical applications because in biomedical field the nanotechnology is helpful to prepare in various nanomaterial size properties in the field. So these are very helpful in medical applications. So bioimaging, tissue engineering, gene delivery, drug delivery, DNA molecule detection, mRNA contrast agent, antibacterial and biosensor. These are the biomedical applications in nanotechnology field. So there is two types of approaches in nanotechnology. The first one is top-down approach and second one is bottom-up approach. Top-down approach means it refers to a subtractive process in which a bulk scattered nanomaterial is divided into smaller ones on nanosize. In top-down approach, there is a various static materials. In static material is in a solid state. So the advantage of top-down approach is large-scale production, deposition over a large substrate impossible, chemical purification is not required. The disadvantage in top-down approach is each product size is distribution, variant particle size or geometry and expensive technique. Second approach is bottom-up technique. In bottom-up technique, it is an additive process. In additive process, it is useful to add the atoms or molecules which combine to form nanosized structure. In bottom-up approach, nanostructures built by atom or molecule by molecule. In this material is charged in the either gaseous state or liquid state. The advantage of bottom-up is ultra-fine nanoparticles, nanoshells, nanotubes can be prepared, deposition parameters can be controlled, narrow size distribution is possible. This is a cheaper technique. Disadvantage is large scale production is difficult, chemical purification of nanomaterials is required. So synthesis particles of nanomaterial is there is two types of approaches. So top down and bottom up. Top down has some physical synthesis methods, that is mechanical aging, chemical aging, bond melting and thermal efficiency and sputtering. In bottom up approach, there is various types of deposition in this: chemical, electrochemical or vapor deposition, sol gel process, spray analysis, laser applications. So in this it has some other types of synthesis, that is green synthesis, that is bacteria and plant extract and fungus. This is non-toxic one. The most of them going in green synthesis method and most of the process is based on only top down, other than that of bottom up. So most of the field is using to prepare the material in bottom-up approach. So these are the methods. So physical method, chemical method and green synthesis method. Most of them are working in chemical method because that is a cheaper one. Thank you.